In this unit, we're going to be talking about gases, and an important property of gases is pressure. Now, we've all heard of pressure. Pressure is probably what you're going through right now, cramming for your next gas test. But you might think of pressure, you might think of a car tire and the gas and the air that is in that tire, which is causing the tire to inflate. And essentially what pressure is that it is the collisions of the gas particles hitting on the sides of whatever container the gas is in. So here I have a model of that. These little circles are the gas particles and the box is the container. And when these particles hit on the sides of the container, they're going to cause a force, right? Because there's a bunch of collisions. And then these collisions are going to cause a pressure on that container. And pressure is defined as force divided by area. So the gas particles are going to create a force, and that force divided by whatever area we're talking about for the container is the pressure. Okay. Now, we know what pressure is, but we need to have some sort of unit for pressure. And the unit that scientists decided to use for pressure many years ago was millimeters of mercury. So how does this work? Now, if you didn't know, we're constantly experiencing a force from the air above us. This is called air pressure. And it's caused by the fact that there's these gas particles, air, and then gravity from the earth is pulling these gas particles onto us and it's causing a force. We don't feel that force because we get used to it, and humans have evolved with just like accepting this force. But there is a pressure from these gas particles. And the way we can observe this is that if we have what we call a barometer. So how does a barometer work? So basically, a barometer, we're going to have a container, and then we're going to place mercury in that container. And then we're going to put a tube. At the top of the tube, we're going to have a vacuum. So there's nothing in here at all. Absolutely nothing. And the air pressure, because the air is outside here, outside the tube, the air pressure is going to push down onto the liquid. And then this liquid, because of the pressure, is going to come up. If you think about it, if you have like a glass of water and you push onto the water, obviously the water is going to come up. Same idea. So the air pressure is going to push onto the mercury here. The mercury is going to come up the container, and at sea level, the mercury will come up 760 millimeters. So we decided to define standard atmospheric pressure, that is 1 atmosphere, standard atmospheric pressure, as 760 millimeters of mercury. Now, using this concept, how can we find the pressure of a gas? Using that, we call what is called a manometer. Let me go ahead and spell that out real quick. M-A-N-O-M-E-T-E-R. That's really nasty. M-A-N-O-M-E-T-E-R, manometer. Okay. And let's look at here. Our first manometer here, we have a gas inside our manometer, and we also have mercury. Now, again, just like here, there is air pressure which is pushing down on the mercury. The mercury is black. And then there's also the pressure of the gas which is pushing up. So you can think of it like this mercury is getting pushed up like this, but then the gas is also pushing it down like this. Now, if these levels were equal, right, if the heights were equal, then that means the pressures would be equal because the forces would be equal. But the heights are not equal. So that means the pressure from the atmosphere is causing a greater force than the pressure from the gas. Okay? So because of that, we're going to go ahead and calculate the pressure of the gas as the atmospheric pressure minus the height. Okay? If you don't understand this, again, I'm going to explain it. It's because of the atmospheric pressure is pushing down on the mercury more than the gas, which is pushing it back up. So it is the pressure of atmosphere, which is 760 millimeters of mercury, or 1 atmosphere, minus the height. Okay. In this example, yes, again, we have the pressure from the atmosphere, which is pushing down on the mercury, and we have the gas, which is pushing. But now the gas is pushing on the mercury more than the atmospheric pressure, right? So that's why the level is higher here, because this atmospheric pressure is not able to push down as much, and the gas is pushing on the mercury. So that in that case, the pressure of the gas will be the pressure of the atmosphere plus the difference in the heights here and here. Okay. And this is also important. Units of pressure, there's a lot of units of pressure. 1 atmosphere, that's the same thing here. We're going to define that as the standard atmospheric pressure. So 1 atmosphere is equivalent to 760 millimeters of mercury, which I explained from here, which is also equal to 760 torr, which is also equal to 101.325 kilopascals. Kilopascals is a physics unit. Pascal is a Newton over meter squared, because force is measured in newtons. Area is measured in meters squared. You don't have to worry about that, but that's where it comes from. 101.325 kilopascals. And I'm going to go ahead and do a few conversions using dimensional analysis so you can see how you can convert these units. Because being able to convert these different units of pressure is going to be important in calculations.